now we're ready to move on in lesson 1.4 to where I said our learning goal today. We need to simplify before we start solving. And we have to know the difference between when we're doing one versus the other. So it says sometimes, now this doesn't happen all the time, so you're going to have to start looking for this. Sometimes you may have to simplify one side or both sides. Both sides might need it before you start solving. Simplifying steps include these two things, and we just practiced them yesterday. Distributive property. So distributive property is actually a simplifying step, not a solving step. It doesn't undo anything. It simplifies for us. And then what do you think our other simplifying step is? What else did we do yesterday? Julia? Yeah, combining like terms. Okay, so when we combine like terms, we're simplifying also. Okay? So we always want to look for, do we need to do either of those or maybe even both of them? And do we need to do them on just one side or do we need to do it on both sides? And when I say on both sides, I don't mean we're going to do the same thing on both sides. I'm saying we have to do whatever that side requires to get it simplified before we start solving it. Okay? Now, take a look at the equation first and always start asking yourself this question from here on out. Do I need to do any simplifying first? Jossie?
Change subtraction to add addition.
Okay, the first thing we're going to do is change our subtraction to add the opposite so that we will be more successful. And we can rearrange things that way also. So 8x plus what?
Negative 21.
Negative 21. We get another subtraction. Plus a negative 5x equals. Okay, so here we're just getting it changed so that we say, well, now that it's all addition, on that left side I can let things kind of like trade places. And so is there some simplifying we should do before we start solving this one? What do you think? Any simplifying? Is there any distributive property to do? No, there's no parentheses in this, is there? Yeah, no distributive property. Is there any combining like terms to do? Yeah. What are like terms on the left side?
8x and negative 5.
Yeah, this 8x and this negative 5x can be put together, can't they? So 8x plus negative 5x. 8 plus negative 5. Remember what we said. If one of them is positive, the other one is negative, they're crossing paths. One's going one direction, the other's going the other. So we have to take the 5 away from the 8, and that's 3. And then which one's further away, the 8 or the negative 5? Which one's further away from 0? The 8, and the 8 is positive, so what our 3 needs to be positive. Yeah, so it's going to be a positive 3x plus negative 21 equals negative 15. Now notice, we just did that on that one side because we're not solving yet. We're just simplifying. Is there any other simplifying you think we can do? In other words, can we put that 3x and that negative 21 together? Are they like terms? No, they're not like terms. We can't put them together. We are ready to solve. So I want you to put right here that in this step, this is when we were simplifying. Okay? We were simplifying right here. That's what we were doing. That's why we didn't worry about doing the same thing on both sides. Now we're going to start solving it. And we're going to undo operations to get things so that we can eventually get that x by itself. So what should be our first move, do you think? Devontae, you want to give a stab at what you think our first move would be in this one?
3x minus 21.
So you want to change it back to how you don't want that add the opposite in it? You want to clean it up, in other words? We could clean it up if it would help us know what to do better. So if we did change it to 3x minus 21 equals negative 15. How would that help you, Devontae? What would you say then that you need to do for your first step of solving? Help them out, Calvin.
Subtract.
Subtract what?
Negative 21, 15, negative 15.
Subtract negative 21 and subtract negative 15? Is that what I heard?
Well, subtract negative 15 by negative 15 and subtract negative 15 by negative 21.
So we're going to subtract negative 15 twice. It's going to get subtracted by both negative 15 and by negative 21. I don't think that would be a good move, sorry. Jossie?
Would you change it to 3x minus 21
Equals negative 15? So you want to clean it up too like Devontae did? Okay. Okay, we can. So if, keep hearing that we want to clean this up. So if we cleaned it up,
then you'd add
maybe that would help us know what to do better, right? Okay, Aurora, what should we do?
add 21 to both sides.
Yeah, we could add 21 to both sides. And before we do that, I just want to stop for a moment and I want to say to you, what if we didn't clean it up? How would we decide what we should do if we're not going to clean it up? Well, you know, if we don't want to bother cleaning it up in the middle of the problem, the only time you really have to clean it up is when you get to the end and you get your answer. Sometimes that's when we have to do our cleaning up. So let's look at this when it was in the blue up here. It says 3x plus a negative 21. How do we undo adding a negative number? Add its opposite. Yeah, isn't that what we're doing in the red step now? We're adding the opposite of negative 21. Okay. Okay, so now we are to what? What does our equation read now? Noah? What's our equation read now after we add 21 to both sides?
3x equals 6.
Equals 6, okay. You guys agree? Negative 15 plus 21, so we got this, you know, one's going this way, the other one's coming this way. Remember when they're crossing paths? We take the smaller distance away from the larger, 15 away from 21. That's 6, isn't it? And then we say which one's further away from 0, the negative 15 or the 21? 21 is, so that means our answer should be positive, okay? So now what would we do? What's our next step? Divide both sides by 3. Okay, divide both sides by 3. And we get x equals 2. Okay, so let's do this in our notes also. Let's put that starting right here. This is all that is when we're actually solving. We're solving once we're doing the same thing to both sides. We added 21 to both sides. We divided both sides by 3. We were solving. Okay. Questions before we move on? Anything on that, what that you're not still sure about?
Mrs. LeGrand, when they're simplifying and changing the, could they change it in the problem that they wrote first, or do you want them to rewrite the problem? So could they have changed that negative to, I'm finding that when I'm looking at work.
Okay, so what they're doing is instead of writing the problem down from in its original state, they're going to write to the first step on their paper.
Right.
Okay. We should write down the equation how it started in class. Okay. So write it down the way it's given in the book, because you're doing a book assignment. Write down the equation the way it was given. On the next line, start doing the things you're going to do. Change subtraction to add the opposite. Then start your simplifying if you need simplifying. Then start your solving and get your result. So yeah, we should be able to see what was its original state. You know what, if Mrs. Wendell or I or Ms. Welkin's helping you with a problem and we can't figure out where your mistake was, and then we say, well, what was the original equation? And you say, well, I don't know. And then you got to go back to the book and you got to find it and all that. That should be necessary. We should be able to look at it from right there at the top and see what did it start off like, so that we know whether you made a mistake right away in the beginning that way. Okay? So thank you for bringing that up, Mrs. Wendell. Okay, number 2. First thing we're gonna do here, Tori,
Turn the negative to the positive.
okay, which negative? Okay, so the subtraction inside the parentheses, we're gonna change to add the opposite. We don't have to do anything with that negative sign in front of the 2 because that's part of the 2. That's a negative 2. We're gonna leave that. That's not a subtraction. But we're gonna change the subtraction that's inside here in the parentheses to add the opposite. So a negative what? 1D. Remember, we can also insert a 1 in there so that we have a number there. And, okay. Okay, I like that move. What should we do next? Are we ready to solve this? Or do we need to simplify first? What do you think? Abby, what do you think? Think we need to, can we go right to solving or do we need to simplify first? Yeah, we have to simplify first, don't we? We have to do distributive property. So we're gonna do, like Abby said, she says, don't we have to do that multiply? So we're gonna take negative 2 times 3 and we're gonna get what? Negative 6. I love how you guys are doing this without your calculator. Negative 2 times negative 1D. Let's just deal with the number parts. Negative 2 times negative 1. It would be a negative 2 times a negative 1 is a what? Positive 2, and then, yes, we have that D. Right? And then equals, does that negative 2 have to get multiplied by that 4?
No.
No, it's not part of that. We're just simplifying the left side then, aren't we? So we have now done our simplifying step. That's all we're gonna do to simplify it because there's no like terms to combine. We're ready to start solving. Now our brain says, okay, I gotta do something that I do to both sides now to keep this equation balanced. So what do you think that move should be?
Add 6 to both sides.
Add 6 to both sides, okay. Now, here's the reason that we can decide, we can read this backwards. This is really 2D add negative 6, isn't it? We can read that backwards when it's addition. So we see that a negative 6 is being added. So to undo adding a negative, we add its opposite. So we do add 6 to both sides. So now we have 2D by itself. And what do we have on the right side? 10. Yeah. Okay. And the last move we're going to make is divide by 2. Divide both sides by 2. And we're going to see that our solution is D equals 5. Okay. And again, we're going to make this little note to ourselves. Starting right here, we were solving. I am finding with all of my 9th grade students, all of them, I'm finding some like really weird things happening in our work. So we have to be really careful and make sure that we're understanding that when we're simplifying, when you can put terms together on the same side, you're not doing it underneath them and doing it twice on the same side. No, simplifying just means bringing together the things that can be brought together. So let me just take a little sidetrack here to show you an example of what I'm talking about. If I had this, okay, and students are saying, well, I know I can put these guys together. I'm hoping that's what they're saying to themselves anyway. And then here's what they decide to do. They decide that that should be then add 3, because that's the opposite of negative 3, and then add 3. And this is what they get. 11 plus 2D equals 17. Did that ever happen to you? You don't have to answer it. That's just a rhetorical question, but is that right? In other words, if we did combine them properly, like we're supposed to, we'd have this 8 plus this negative 3. What's that really become? What's 8 plus negative 3? 8 plus negative 3. Positive 5, isn't it? So those would come together and be 5, and then plus our 2D equals 17. A little bit of difference, isn't there? So when we're simplifying, we're bringing together, not trying to do the same thing twice on the same side of the equation. Okay? Be really careful about that. That's why I'm trying to talk so different. I'm trying to get you to see the difference between simplifying and solving. Okay, let's go to the back. Woo! What do you suggest we do first here?
Change the, subtraction.
Yep, we're gonna rewrite this with subtraction, any subtraction being add the opposite. Well, there's no subtraction there, so no reason to change it. If it's addition, leave it alone, don't mess with it. And then this subtraction is gonna change to add. What's being subtracted? 4x is being subtracted, so we change it to the opposite of 4x, which is negative 4x. Okay. We haven't even really simplified, we've just renamed it. That's all we've done so far. Okay. Can we simplify? Should we simplify? Okay, we do need to simplify. In fact, it's going to take us a little bit extra to simplify this time. We're going to not get to solving for a little bit here. What should be our first simplifying? Abby? Yeah, we're going to do our distributive property, right? Okay. So 2 times x class is 2x. Bring that addition sign down that's in those parentheses. 2 times 2, 4. Bring along the tag along, plus negative 4x, and then equals 40. Okay. Ready to solve? What do you think, Devontae? No? Why not? What do you want me to do?
Add 2x and -4.
Put those together. Yeah, they're like terms, aren't they? These guys are like terms on the same side, so I can bring them together. I have a 2x plus a negative 4x. That would be a negative 2x. Positive 2 plus negative 4. One's going this way, the other's going that way. Subtract out the shorter distance. Negative 4 is further from 0, so our answer will be negative. Bring along that plus 4 that's hanging out between the two of them. It's the tag along on that side, and equals 40. So we had to do 2 simplifying steps. Do we have any more simplifying steps to do? Calvin, you want me to do another simplifying step? Can I see your head shaking, or is that going with your leg?
You could
Okay, what do you want me to do?
subtract 4.
Subtract 4 from where?
40.
From 40? Okay. Should I subtract it anywhere else then?
And then 4.
And the 4. Okay, now I'm starting to do the same thing on both sides, aren't I? Am I simplifying anymore?
No.
Now I'm what? Solving. So you're starting to solve for us, aren't you, Kelvin? So we are actually, this was our simplifying right here. And after we did our distributive property and our combining those x's, those like terms, now we're ready to start solving and do what you want us to do, Calvin. Subtract 4 from both sides. We get negative 2x equals 40, take away 4.
36.
How much?
Oh, wait, never mind.
You say 76?
Oh, 36.
36. Oh, 36 is right.
Oh.
I just didn't hear it, I don't think. Why was that so hard to do? Take 4 away from 40. What? Oh my goodness. So painful. What am I going to do with you guys? Okay, what are we going to do next? Divide, we don't divide
36
negative
by
2 by both
negative
sides. We divide both sides by negative 2. Yeah, we get to talk properly. Okay, we divide both sides by negative 2. And over here they cancel. We have x by itself on the left side. Positive divided by negative? Negative. How many times does 2 go into 36? 18 times. Okay. So once we started doing those things on the same side, now we were solving. Okay? You don't have to make that note to me in your homework. but I want you to have the thought, what am I doing right now? Am I simplifying or am I solving? So that you get so you just know the difference. Okay, write and solve an equation to find the value of x in the triangle shown. So look at this triangle. It has an angle up here that measures 35 degrees, has an angle down here in this corner that measures 56 degrees, and then it's got the other angle over in this corner that measures 2x minus 4 degrees. How are we going to set up an equation for that? I'm thinking that since the teacher wrote the sum of the angle measures in any triangle, I'm thinking that that would be some valuable information that would help us. Anybody happen to know what all three angles in a triangle add up to?
180.
180. Okay, they're good. Okay, so they add up to 180 degrees. The sum of the angle measures is 180 degrees. Give me an equation you think we could use. Cody?
180 minus 92.
Okay, and then what? I haven't heard an equation yet. 180 minus 92.
And that gives you your answer for the missing degrees.
That gives you your answer for what missing degrees?
So the right angles.
Well, we don't know if it's a right angle. It's not marked as a right angle.
Well, it's not one.
Okay, so what are we going to set it equal to then? 180 you want minus 92 equals what? X, just X. I think we better do it the way it says here. The sum of the angle measures. That says we should add, not subtract. Let's do that. Sum of the angle measures. 35 is one of our angles. Plus, what's another angle measure?
57.
57. I bet that's where Cody got his 92. Plus 2x minus 4 equals 180. Yeah, there we go. Okay, there's our equation. The sum of the angle measures, there's three of them, equals 180. Okay. Well, we got a subtraction there, thinking we want to take care of that. So 35 plus 57 plus 2x plus negative 4 equals 180. How do you feel about these parentheses that are in there right now? Are they playing a really important role or not?
Yes.
Are they significant, or can we just like say, get out of there? What number? What invisible numbers here? 1. And this is a positive 1. What happens when you multiply by a positive 1?
It saves itself.
It stays itself. It stays the same, right? So in reality, couldn't we just ditch those parentheses? Yeah. So we have 35 plus 57 plus 2x plus negative 4 equals 180. Or if you really want to do the multiply, feel free. 1 times 2x is 2x plus 1 times negative 4 is negative 4. Okay. Are we solving yet? No. Okay. Now what? Ready to solve?
You add the terms.
Add like terms. We got some like terms we can put together, such as.
35, 57, and 84.
Oh, those three are all constants. They are like terms. They can be combined. 35 plus 57. Cody already told us that's what?
92.
92 plus a negative 4. 88. Okay, so 88. All those constants come together to be 88. And then we got our tag along in the middle there, the 2x. Okay. Any more simplified? No, we're finally ready to solve. What are we going to do?
Subtract 88 from 180.
Subtract that 88 from 180. Only from 180, Cody? Really? From both sides. From both sides. Otherwise, the person on one end of the teeter-totter is going down and hitting the ground hard. And now we have 2x equals
92 negative, or 92.
92. And then we have,
46.
what do we gotta do next?
Divide this by 2.
You divide each side by 2. And then we say, 92 divided by 2 is what, Cody?
46.
46. Okay. And since that x is involved in an angle measure, what do you suppose its label would be? Degrees. We found out that x is representing 46 degrees. Okay, answer me, Cody. Is that a right angle?
No.
Why not?
Because
Because what is it then? What is its measure? It's an acute angle, okay? Because to be a right angle, it would have to measure what? 98 degrees. What does it measure?
46.
How much?
46 degrees.
No. They asked us to find x, didn't they? What if they had asked, what if this is a question on that test you took yesterday in the lab, and this was a question on there and it said, find x. And you get there and you say 46, and that's one of the multiple choice answers. You're happy, you click it, you go on. What if this is what they had said instead? Find the measure of the third angle measure, the unknown angle measure. Because 2x minus 4 was unknown to us, wasn't it? It was called 2x minus 4. We still don't really know what that measure is. What if it had said that instead? Well, 46 was in the answer bank, and you already chose that, but you just chose the wrong one because they want you to find the missing angle measure. So, Jossie, tell me, what would it be? Pardon? No. Follow along with me. Cody.
88.
88. How'd you get that, Cody?
I multiply 2 by 46 and then subtract by 4.
Yeah, take the 2 times our 46 that we just got, and then we subtract 4 from that. 2 times 46 is 92. 92 take away 4 is 88. So sometimes an angle measure might look like a right angle, but it's not necessarily a right angle, and especially if it's not marked as one, until we can prove that it is. So then 88 should have been the answer in the answer bank, and that would have been the right answer. We always have to make sure we read what are they asking us for and understand that. Okay? Okay, so